In this video we're going to build a ProtoBot, show you how it works on the inside, how to control it and customize it, and even start learning how to code with it. But first, let's unbox it. Inside you'll find everything you need to bring this mini robot to life. ProtoBot can be ordered in 3 kit levels: the beginner, pro and the DIY edition. All 3 kits include a booklet to guide you through the build, but you can also use this video to help you out. If you got the beginner level, you can go ahead and skip to this part of the video. Both the beginner and pro editions include a transparent shell, but for the DIY edition you need to 3D print it yourself. Just download the file and print it with any material or color you like. Just try and keep the eye area a light shade so that the LED colors can shine through it. If your printer doesn't support multicolor, you can also print it in white. Next, carefully take out all the remaining parts and lay them out on a clean surface. The Pro Edition involves a bit of soldering, so go ahead and turn your soldering iron. Remember to be careful when using this tool because it gets hot. If you never soldered before, don't worry, we'll guide you through it step by step. But if you're underage, it's best to ask an adult to help you out. It's also very important not to use flux, as improper cleaning can damage the onboard sensors. We can start with CodeCell, which acts as the brain of your robot. First, insert the pin header into the plastic cover to keep it stable. Then slide the CodeCell into the pins. Make sure that the sensors are facing upward. Now use the soldering iron to solder the 5 pins to the pads. Next, align the flexible PCB onto the CodeCell with the adhesive cover facing up. To prevent it from moving, insert 2 M1.2 screws to keep everything aligned. Once the boards are aligned, you can start soldering the pads together. When you're done, pop the boards out. Before continuing, I highly recommend connecting the battery, just to confirm that all the LEDs are flashing blue. If they don't worry, just recheck that every pin is soldered correctly. If everything looks good, you can remove the battery and screws, because soldering was a success. The next step is peeling off the adhesive cover and carefully sticking the flexible PCB onto the housing. This is probably the trickiest part of this build, so take your time. Start from the bottom corner and use the 2 circles to help you align it. Press down on all areas, including the LEDs, to make sure everything sits securely in place. This is how it should look. Now we just need to secure the CodeCell with the 4 M1.2 screws. Next, slide each motor onto the flexible arm, matching the 2+ marks. Solder the motor pins and repeat this for all 4 motors. After soldering, gently fold the motors so they fit into their slots. Both folds should be on the CodeCell side. Now secure the 4 motors using the 8 M1.6 screws. If you've got the beginner level, welcome to the build. The pro builders just finished soldering, so you can start from here by unpacking the bag of the wheels. Before continuing, just connect the battery to confirm that all the LEDs are flashing blue and that the motors are spinning. Place the power switch and battery into position, routing the wires neatly into the gap. We can continue by sliding the aluminum hubs onto each motor shaft and tightening them using the provided screws. Next, stretch the silicone tires over the hubs so that they fit snugly in place. If the tires look slightly misaligned, just gently roll the robot onto a flat surface and it should align itself. Finally, put on the cover and secure it with the 6 remaining screws. If you'd like, you can also use these 4 screws to attach the breadboard, which lets you expand your ProtoBot with other I2C sensors and displays. Once everything is assembled, just turn on the power switch and your ProtoBot should come to life. The eye will flash blue and the robot should start moving back and forth. Next, you need to connect it to the MicroLink app. Just tap the add button and the app will search for your robot. Once it's found, give your robot a name and the app will open the ProtoBot control panel. The robot's eyes will also turn white with a fading comet animation. If you'd like to change the default color, you can do it via the settings. We recommend charging the robot before using it for the first time. While charging, the animation will turn red, yellow and green. Once it's full charge, it will turn green and flash red once the battery is low. If the eye is blinking blue, the robot is being powered over USB with the switch turned off. In the app you will also see the status of the battery, the heading and the RSSI level. The default screen will show the joystick, which lets you manually control the robot forward and backwards in any direction. Going on the left and right arrows will make the robot spin clockwise and anti-clockwise. You'll also see a set of buttons for quick actions. The first button lets the robot try and drive back the path it just took. The second enables the front proximity sensor, helping the robot avoid hitting objects while driving. It also makes the robot behave a bit more playful when idle. The third button aligns the robot to true north, which can be very helpful when working with multiple robots. The next button allows the robot to avoid overhead obstacles when it's upside down, which can also be used as a fun little game. The last button lets you adjust the robot's maximum speed, so you can drive it slowly, medium or full speed. If you tilt the robot upright, it will also attempt to balance for a few seconds. The performance of this algorithm depends heavily on the surface, so we recommend testing it on carpets. Switching to path shape mode allows the robot to drive in fun shapes. Just adjust the size and press play, and the robot will automatically drive in the selected path shape, either once or continuously in a loop. There is also automation mode, which is like a simplified version of block programming. These 5 empty blocks act as your sequence, so when you tap on a block you can choose an action. For example, we can start with tap, then drive forward for 2 seconds, and finally draw a figure of 8. When you press play, the robot waits for the tap, then perform the action. There are different blocks you can try, and you can also loop them or save them and trigger them using the proximity sensor. ProtoBot also comes with an Arduino library that lets you access all its onboard sensors and features using simple API functions. This means you can easily read sensors, control motors, and interact with your robot with a few lines of code. The library also includes multiple examples to help you get started quickly. To upload a sketch, simply connect the robot over USB, select the COM port and choose the correct port settings. We are continuously updating and improving this library, so make sure you keep it up to date. Whenever there's a new firmware, the app will notify you and let you update the firmware over the air. If you're connecting an external I2T sensors, you can enable data logging in the settings. This will print whatever you're testing in your code, and you can also export the readings. The GitHub repository also includes accessories you can 3D print, like a sidecar, a camera mount, a marker holder, and more. All these designs are open source and you can 3D print them at home. They attach easily on top of the robot using the screws. We encourage you to learn and create your own accessories, or even modify these files for your own applications. If you'd like to learn more, visit microbots.io/protobot and join our community. Happy robot building!